This is what we've been thinking and talking about in terms of the data cache capabilities since 2017. So we're really excited to be able to show that those requirements that we had identified back then, that we're actually starting to solve them, right? And so around the room, we've got posters of the architecture up there. So after we've gone through it, please feel free to spend time at it, write questions on them. You know, we put them up for you to be able to do that type of stuff if you don't want to ask questions out loud. Or if you think about something and you don't want to lose it, go write it down on one of these posters for us, because this is going to be a fairly substantial change in the way we've thought about our data in this community. And it's one of those things where I think we've all had an idea of what this was going to bring us, but now that it's here, we get to reshape that, right? so we all thought we knew what we were going to do with Irwin and what data exchange was, and then every single time we talked about a data set, you know, we had to get into stuff that we hadn't considered. And this data architecture does the same thing for us. And so I want you to think about the different components of it. The proof of concepts that we're doing, we focused on fire environment, and we've done that for a variety of reasons. One, the Fire Environment Committee has done a lot of work on defining capabilities that they needed that were kind of agnostic of applications. And so they've got kind of some core work that they've done. The Predictive Services Oversight Group has a long-term plan that's going to be presented to NWCG, NMAC, and the FMB here in a couple of weeks. And data and information is a big component of that. And it's a business area that's pretty data intensive, and it gives us an opportunity to look at ingesting different data in different ways and then producing different data products on the other side. And we kind of wanted to leave like incident and resources alone, because Irwin is kind of got that under control. IROC is getting ready to go into new contracts, so we don't want to, we just kind of want to let what's working well in the community work while we learn a lot on this fire environment data. And so the first use case that we're going to go over today is the field sample data. The second use case that we identified was getting reference data out of our enterprise data governance tool, and they've done some work on that today as well. And then the third use case that we'll be getting to next is around the RAWS data and looking at streaming data. So when we get through this, these proof of concepts that we're doing, we're going to have a good portion of kind of the total capability built out. Each of these use cases kind of build on each other. And so, so it's kind of like we're in a little building this out, but it's building the capability that we can then start just plugging through, right, with different data sets. So we talk about these as proof of concepts, but in the meantime, Patricia and Cole and I have been meeting with the Forest Service CIO, Chief Technology Office staff, and with the USDA EDAPT team to figure out where this is going to land for production. And so last week we got word from the USDA EDAPT team that they're not ready to do this. So what we're asking for is a little more than they have capacity to do at this point in time. So it looks like we're going to get a waiver from them. And so now we're working with the Forest Service CTO staff to see if this goes in Skynet or in a different cloud environment. And we hope to have an answer on that soon. And so Patricia has started working on some of the contracts, and so we are moving forward. We have funding, and so I want you to watch what we are showing you today, and there's these conversations that we're going to have over this next week, because what this is doing for us is it's allowing us to change the way we think about how we deliver data and information. And even though the field sample database, previously known as the field moisture database, right, is like a little teeny database, right, compared to like IROC or Irwin, you know, right? But it's still like has given us a ton of opportunity to think about, oh, how do we adjust this data? What makes sense to do in the application versus what makes sense to do in the enterprise level tool? what reports should be going where does the data come from to display, all of those types of things, and the potential for any single individual application or business area is, I don't know that there's a single place that couldn't potentially be impacted by what we're going to be talking about today. So start keeping those things in mind. This is what we're going to talk about in our breakout sessions, because if you've been around for very long or you've been on application teams at all, governance is an issue, right? And when we think about making this type of change to our enterprise, there's lots of really good things that come from it, but only if we govern it well. And recently, Gabriella and Katie O'Hara and I were spoke at the Enterprise Data World Dataversity's digital conference. And again and again and again, this theme keeps coming up of, you can do all kinds of things with technology and data, but if you don't govern it, it'll all fall apart. And so this governance idea is one that we really need to think about, and in this environment is complex because we're talking about data from the states, we're talking about data from 5 federal agencies, it's how do we, and multiple business areas, right? So how do we actually represent that, get the right folks on that, on whatever type of governance we're going to provide, right? And what does that oversight body need to be and do and pay attention to? So I want you to be thinking about those things as you watch these demos and as we talk through this. The other thing that I will say is that we really built a lot of time in this agenda for conversation. And so I would encourage you to be thinking of those questions and ask them, because if you have a question, I can guarantee you there are other people that have the same question. So this is a lot, and for those of us that have been kind of mired in it for months, I'm looking at Cole, meaningful eye contact with Cole here.
More than months, yeah.
Months and years, it's like there are things that kind of make sense to us that aren't going to make sense to you, and so we want you to ask those questions. And if you don't ask questions, then I'm just going to give you a heads up that I will be going through and calling names. To get your opinion and your perspective, right? Because we want to hear. We cannot be successful if we don't hear from you. And so we need your perspective and your input in this and your thoughts. And it doesn't matter how random it might feel, we really do want to hear that. So
I have just a random question, and you feel like, don't care, we'll do that some other time. But wasn't one of the things that came from the fall summit as well, that one of the lower line, I won't say lower line groups, but one of the things that was when the group was solicited about what would really be helpful is in the phase 2 or maybe even a pilot of merging that legacy ROS data and the, okay. So that didn't fall away.
no,
Okay.
we still have that.
There's a big deal.
Well, and so I think you'll see, so think about that. So that conversation that we had was we've got kind of different versions of ROS data, right, and IROC data, and how can we bring those together in a way that you can traverse those different time frames and be able to kind of have a seamless view of some of that data. So watch, right, and see some of the things that we're able to do in this environment, because that's how we're going to solve that. And I have no doubt that every time we bring these guys this big thing, it's like, oh my gosh, this is so hard, this is so big, here you go, and they're like, oh yeah, we can do that like this. And so it's amazing to have these guys that have this experience and understanding of what it is we're trying to do, and so I hope you'll be as excited about all of it as I am.
All right.
So,
Cool.
There you go.
Carlos, you want to start?
Sure.
All right.
Do I get up that?
You get up there,
yeah. Take my computer?
Yes.
Is everyone familiar with the field sample data set? What it does?
I bet nobody is.
No.
The fuel sample,
Tell them what one that is.
National Fuel Moisture Database. So it was out of Missoula on a desktop that all folks would use across the country. And it's basically everyone had a shared login from different GACs and field sample site locations, but there's field sample site locations and people go out and they take off a needle or, and I'm not an expert in it, but different types of fuel, they dry it and then they get a fuel sample moisture level so that scientists and decision makers can decide how the fire is going to burn and all kinds of fire weather predictions. And Travis, I know you're on the phone, like probably like dying, my horrible explanation, but I just want to.
You're doing great.
Oh yeah, right. Thank you. You want to add anything to that, Travis?
It's a little hard actually for me to hear in the room with some of the background noise, but yeah, I mean, I think there's probably quite a few people that are familiar with the National Fuel Moisture Database. So the functionality within that, I think, was somewhat limited, and I think you'll see that through this demonstration what some of the extra possibilities are. Maybe if there's any specific questions, we could answer them.
Okay. Yeah, and it's currently in a transition where we're trying. So there was basically version 1, and now we're trying to, not our group, but they're trying to make a new collection platform so that it can be more enterprise wide, which will eventually, that new front end will come in right into this data environment. But for now, so that our first proof of concept has to do with the version 1 of the field sample database. Okay, Carlos, you can take it away.
Okay, thanks. So like I said earlier, I'm Carlos Bossi, and I'm one of the architects that's been working on this. And so what I'm going to do is actually show some charts and reports and dashboards and things like that, which everybody loves to see. That's kind of like the end of what we do, right? But we do a lot of background work and a lot of behind the scenes work to get there and to try to get there easily. So as I refer to those charts and other things that we're doing, I also am going to refer to this diagram that's up here. It's also, I think, the same one that you see up on the posters here in the room. And I know the colors aren't exactly the same, but they say the plotter ran out of ink or something. I don't know what happened.
Ran out of yellow,
Oh,
so.
ran out of yellow.
It's ran out of yellow, it's got kind of the Easter theme going.
But it's essentially, it is the same diagram, right? So just in case it looks a little bit different. But one of the reasons I'm going to refer to this diagram, and I know this diagram has a lot, there's a lot here, so we can talk about each area here in a lot of detail, and we probably will over the next few days. The main point we're trying to make with this architecture is that we've all been in a situation where we need data, and we go try and find it, we go get it from here, we get it from there, we put it in Excel, we run some SQL queries, and maybe it takes us 3 or 4 or 5 days or 10 days or 3 weeks, and we finally got what we want, and now we're able to show a little dashboard, and we were able to do our analysis. So the idea behind this architecture is to stop all that work and really to focus on the analysis. The idea here is that we deliver data to you the way you need it. Now, how do you need it? Well, Rochelle needs it differently than Emmy, and and Patricia needs it differently than Don, and so everybody needs it in a different way. So we're not here to try to tell you this is how you need it, or this is how you should use it. We're here to understand how you need it and then provide it that way. So in this architecture, you see various zones of data and things like that, and it's all about providing different mechanisms for people getting the type of data they need and want when they need to use it. So what I'm going to talk about right now is when I show those charts and diagrams, is the analytic zone. And the analytic zone is really, maybe some of you have heard of it. It's a data warehouse type model. It's a star schema type model, but it's a way, if it's modeled properly, for people to get data in many, many, many different ways without us actually having to deliver any particular report or dashboard to them. They can do it themselves. And it becomes very easy, what I call drag and drop. Any business user could do it, or anybody who knows how to use Excel or any other tool. And so I'm going to demo that in a minute, but what I want you to understand is that we're trying to build out all the pieces of this architecture, and in the end you see the little demo, and there's a lot going on under the covers. And one of the things that's going on is that we want to build these models properly, because almost every organization fails. I get to see a lot of organizations and how they work, how their data warehouse works, how their reporting system works, how their business intelligence works. And it almost always fails because of poor data models. Of course, it fails for other reasons too. There's bad governance and bad or no governance, right, typically, and a lot of other things. But when we look at it from a technical point of view, the data models are poor, and it makes it very, very difficult for people to do what they want to do. So a few things are going to be involved here. We kind of have a version of the landing zone, the refine zone, and the analytic zone going on. Essentially, what we did is we asked Travis to give us an example of a dashboard that they built today. And here was the example of that dashboard that he gave us. This is obviously just a JPEG or a screenshot, right? It's not functional, but it shows us the data about fuel in a particular location or a GAC over time, right? So from 2001 to 2023, there's various measures that are happening here. There's a couple of percentiles being calculated, the third percentile and the 10th percentile. And then there's a minimum average values and then the current average values and then just the overall average values by month for this particular GAC and this fuel. So what we did is we decided, well, we can build our data model to support this, and to support it not just by building a single dashboard, but by being able to build it in a lot of different ways, in many, many different ways. So what we did is we came up with this. And as you can see, it's similar, obviously not exactly the same. One of the reasons it's not exactly the same because we don't actually have current data. The database we used only had data through September of last year. But if you were to compare the numbers, the numbers through last year are exactly the same. In fact, all the third percentile calculations, 10th percentile, the minimum averages, those kind of things are the same. But it allows us to do our own analysis. If I'm looking at the year 2020 and I want to look at a different year, I want to look at 2020 instead of 2022. I want to look at 2021. You see that I get the immediate changes and the immediate analysis. If I want to look at a different fuel instead of pine, want to go to oak and switch to that, I can do that. If I want to switch my fuels, if I want to switch the site. And of course, this is a simple way of providing the data in such a way where somebody can build thousands of these different dashboards on their own or do their own analysis. If I want to switch to a different GAC, I get that change. And these changes are being calculated for the data over time, right? So from any data we have from 2001 to current, everything's shifting and changing as you see it. And you see the numbers at the bottom changing as well, so that we get that data. And really the purpose here was to try to reproduce that same visual that we had. One thing I wanted to show is just, when I go back to 2022, and if I want to go back and go back to Anderson, and I don't have the exact titles because we don't have these named exactly the same way. We're still in a bit of POC type work, so we don't have it named exactly like they do in Travis's chart. But if I look at the same fuel for the same time frame, right, and you look at his chart, the numbers should be exactly the same. The lows are 114, 105, 111, 114, 105, 111. And again, that's not hard coded, right? We're calculating all that on the fly with the database and data mart supporting it behind the scenes. So this was just an example of what we could do fairly quickly if the data model is correct, and then all that architecture is built properly. Delivering that data in this form lets us answer questions that haven't been asked yet is really the key, right? If you don't have to put in a ticket to IT or you don't have to ask somebody for data, the data is there for you to use, and then you can create a whole new report and create a whole new dashboard if you want. Other options we have here are obviously, again, in trying to produce the report that Travis gave us, there's really 3 dimensions: the year, the site, and the fuel. But there's actually many, many, many more dimensions. And so there's many more capabilities that's built into this that, again, weren't really required, but you get those for free in a way because, again, the data model is a good one. And I'll show some of those capabilities there in a minute. And then some of the use cases that were brought forth that we're trying to solve as well. But any questions about this or any more comments?
I think the big thing is that we've all seen dashboards, right? But if you haven't been involved with making them, if you talk to somebody like Craig Thompson, who will say, you know, hours and hours and hours and hours and hours munging the data, right? And that's really the thing that we're trying to address here. So the dashboards are great, right? You've seen them, but we're trying to make them faster and easier because the data is modeled appropriately.
Yeah, I think another point to make is that this isn't done in an application. This is done within the data architecture. So you don't have to bloat your applications in order to do it. You know, the data is just always coming in, and this is created on that right side or in the middle and viewed on the right side of that architecture. So we're always trying to extend our applications to do things that maybe they weren't designed to do. And this completely takes that headache away so that the applications can focus on exactly what they were designed to do and what their expertise is rather than chasing their tails.
Yeah, and I think a good point is that separation of duties. That I think that's kind of what Emmy's talking about. An application needs to store data in the way it can best manage the data, right? And it needs to manage it in a certain way that is very different from what I'm doing here, right? I'm taking aggregates over a 20-year period and looking at those. And some of those aggregates, in some cases, can be millions and millions and millions of rows of data, right? And the application doesn't worry about that. It doesn't need to worry about, should it, right? The application should, often the applications are very transactional. They store a record, they manage that properly, and they're able to update that record, change it, maybe they remove it or whatever they need to do. But they don't necessarily deal with this type of data structure. So the idea here is that we deal with this type of data structure, that the application focuses on what it does best, and then this architecture does what it does best.
And the data is kept up to date automatically, which it pulls the data from the source application. And even if it's changed after the fact, we can collect those changes and corrections and apply them automatically without manual intervention to keep the data up to date. So no fuss, no muss.
Yeah, and I think that's exactly where I was going. You know, we create these one-off dashboards, and you know, it's somebody that works on it for, you know, maybe a month or two, but then, you know, maintenance falls off. So this is much more centralized, more efficient way to do it, to maintain the data and not have to do that maintenance on things like this for that specific reason. So, yeah.
And as you see, I've kind of been changing the dashboard as everybody's been talking here. And one of the things you'll notice is that if I change the year from 2022, let's say to 2020, for this particular GAC and fuel, you'll see that what changes is only the blue line of the current year that I've selected, because everything else has been calculated over that long period of time for that combination of data. But again, we would like to be able to make it so that you pick any combination of data you want. Maybe you pick multiple fuels together and see how those combined look, or maybe multiple locations or multiple, you know, different ways of looking at it. And we'll show you some of those capabilities in a minute. But the idea is that this doesn't stop here, it just starts here. Should I go and do which one? The use cases one that we talked about, that was the one we were going to do second, right? Yep. So this is just an example of the same data model. And this is some data that we're kind of showing the left and right side here. On the left side, you see a 3-year period because I have a slicer up at the top with picking the last 3 years. And it tells us some data about the sampling, how many unique species by GAC we have in each GAC. So you can see there what that looks like, sorted in alphabetical order by GAC in this case. How many sites we sample by GAC, and in this case it's sorted by highest to lowest, right? And again, all of these you would be able to do yourselves if you wanted to. And so there's been 168 sites in Rocky Mountains that have been sampled and 5 in Alaska. So those are again, greatest to least. And then the sites sampled by state, how many sites, and this is just the top 10 because there's a lot of states that are in here that have 1 or 2 or 3. But in this case, you see where the sampling is taking place, California being the most, Colorado being number 2, and so on. And now you see the charts or the tables on the right, they essentially support those charts. The top 3 tables are the same data really as the charts on the left. But we also have a last sample table at the bottom, and that tells us when the last time a sample took place. And so one of the things I may be interested in is I'm from New Mexico, so I want to see what's been sampled in New Mexico, what's going on. I can click on New Mexico down here at the bottom left, I think. There we go. And then I just see New Mexico, right? So I see that New Mexico makes up part of the Southwest GACs, not all of them, right? 43 of them. It also makes up part of the unique species of 27 of them. And you see the data just for New Mexico. You also see that I have the people who have been sampling in New Mexico. And in red, I've highlighted the sample that's more than 2 years old. So if a site hasn't been sampled in more than 2 years, it's going to show up here. And I think I made it 2 years in this case. And so then that way I can start to see, well, where am I deficient in working at a certain place, or maybe I should be sampling. One thing I can also do is go back and look at everything, and I could actually, let's see if I can get this to respond here in a second. I think the sharing makes it a little bit slower. There we go. I could also sort this in reverse order and see all the reds at the top now. And there you see all the ones that stand out to me as haven't been sampled in a while in this 3-year period that I'm looking at. Again, if I go to just California, I would just see those, and so on, right? So now California, because it's broken out, it's in 2 different GACs. You see the data just for unique species. That would be California for those GACs, and how many sites have been sampled in each, and so on as well. So very interactive. It allows you to, again, kind of create your own dashboard or do your own analysis, even do more drilling down if we wanted to do that into more detailed type data. But also at the same time, I can display the relevant summary or aggregate data with the detailed data that's more like operational here. And as you're doing research or doing analysis, you also can take a look at that detailed data and understand what needs to be done or what actions need to be taken.
Yeah, this is almost like a QA/QC that I can see applied to a lot of problems that we talk about, like how many fire point of origins aren't within the perimeter. You could easily answer that question. It's kind of hard for us to answer now, but you could answer that. And then you've got the red, public embarrassment always helps.
Yeah.
And
So Travis, can you talk a little bit about what this type of data capability does for you?
Well, I think you guys are hitting on it. It helps you understand who's active. I know taking on the fuel moisture database project, it was informative for me to just go explore the data, and using tools like this to explore the data really helps to uncover a lot of things. You guys were hitting in on, Carlos, I think you said, well, you're from New Mexico, so let's look at New Mexico. I work in the eastern area. I work in Minnesota, but I know that I have people in Wisconsin that are doing data collections. I just got an email from them and seeing this information, but it doesn't show up in here. So it gives me a target to say, hey, maybe we should talk. I know the reasons now are the issues associated with the database, and that's why we're trying to work through that. But it is very helpful information to just be able to slice and dice through all sorts of different ways. Actually, one of the things I'd say that was very interesting about working on this as a pilot is having the data architects try to put something together based on what they thought we'd be interested in. Sometimes that results in something like, well, that's probably not something we do, but then all of a sudden it's like, hey, I like what you did there. So all those things are benefits of what we're seeing here. That's a look more at almost what's happening in the background. It's not highlighting the actual samples that are being taken and their percent moistures. It's the other data that you can get out of it.
Yeah, I think, for a long time, I think about, years ago, Steve Larrabee working through figuring out what fire, which areas have got their fire reports done, and trying to figure out, who was behind, so you could go in and have conversations with them and try and get their fire reports done, right? So we're always in this situation where we're trying to get our data situated so that we can use it, right?
Mm-hmm.
But it's always been such a manual process to actually understand the state of our data. And what I like about this particular view is that it gives us some insight into how we'll be able to slice and dice our data in the future and understand the state of it, the completeness of it. And that's going to help us in all kinds of ways, right? So first of all, getting it cleaned up, getting it complete. And as we can start looking at it in different ways, we can document it, right? So like how Carlos has got these items in red, right? Well, it makes it faster for us to actually see and go find and correct things. And so the demands on our data are going to be increasing exponentially. So if we don't have a way of proving that we are managing our data so that it's reliable and available for the people that need to use it, then other people are going to do it for us, and we really don't want to end up there. So I really like this view because like Travis said, it's kind of gets us behind the scenes of what we've normally been looking at in our data and allows us to start understanding it from different perspectives and asking different questions. Anybody on the line have any questions or comments about this?
Steve threw something in there in the chat.
Good job.
Steve, you want to talk to that?
Well, first of all, I love what I'm seeing, but one thing that's kind of different is, even with some of these better tools to kind of inform us about the data behind the data, one thing that's changing with that field samples database is that, we're not going to just include things that are measured with percentages. And so, whereas before I think we might, look at what kinds of species were being measured, now there any fire environment measure that can be, sampled empirically, I think is a potential candidate for the data set. So it's not just, what kind of variation are we seeing within a particular metric, but what kinds of metrics are we using to measure that fire environment condition as well.
Yeah, and I think that goes to what Carlos was talking about, right? So getting those data models defined well is so critical, but once we've gotten those models defined, then essentially those models tell us all the ways that we want to be able to slice and dice this data. And so that model can then shift and move based on the parameters that you've given it, right? But we don't have to go build it again. And so that's such a critical part, and it's something that we're going to be spending a lot of time working on in this community as a whole in the future, is that we've got to get those models right in order to be able to optimize what it is that we want to get out of this. So then we should be able to change those and adapt to those quickly, right? That's part of the intent as well, is that that it doesn't take us years to produce a new report, right? That if we've got them modeled well, that we can produce them much more quickly. Craig?
Yeah, thanks, Carlos. That's awesome work. I see you're using Power BI, and I'm just assuming that you're going to be application agnostic with your methodology.
Yeah, this will work the same in Tableau or whatever your favorite tool is, I guess, right? But we just had to build it in something, so we use Power BI.
Okay, great, thanks, great job.
Yeah, the tool, the front end tool itself will, I guess, going back to the data models, right? And again, Rochelle just mentioned, and I'll talk a lot about them and the architecture and the models. When modeled properly, the tools understand the model. And these tools expect the model in a certain way, and if it's that way, they work a lot better. And Tableau does as well, and any other tool will as well. whether you're using some other reporting or dashboard tool, or even Excel, right? If that's, the way you want to look at the data. And one of the things I'll say is, for example, when we put this dashboard together, these use cases were specified to us as, hey, can we show this? Can we put this together and show it as a use case? And when we had already built the data model for it. So again, building the data model properly meant we didn't have to change anything. We could already produce these charts. And then later on, Rochelle said, or I think it was Rochelle, said, well, can we show the last day a site was sampled and who did it? Well, again, we didn't change anything. We just added it. We just added it here because the model supported it, right? Again, built properly, the model supports it. So, and then the tools, modern BI tools, modern reporting tools, all again, they do better with good models. I mean, any modern BI tool can write a lot of SQL behind the scenes to try to get some data to you and make it happen. It'll be slow, it'll be ugly, it might be wrong, but when it writes SQL for something like this, it actually is very clean. And so being that it expects the data to look that way, then it works very fast. Again, I can show simple examples of I just want to change the data. Instead of looking at the last 3 years, I want to look at the last 13. And that quickly I get that result, right? Because again, the model supports it. Now you see that we have a lot more sites that, no, not that many more, I guess. We got a few more sites that haven't been sampled. But you see again how the data model reflects that and answers questions that I haven't asked yet.
Any questions or comments in the room? So while this may be data that you don't necessarily work with every day, think about the concepts, right? It's, think about what reports, what queries, what questions have you been asked that if your data was modeled like this and you could go to something like this, how much better would life be, right? Or better yet, you could just send somebody to it, right? Say, you don't actually even need me to answer this question for you. Go to this site and you can filter it the way you want to filter it yourself, so that really is what we're trying to get to, right? As much self-service as possible, so that we can reduce the number of these ad hoc queries that just show up at the last minute and we don't have any way to respond, right? It's weeks worth of data calls and data munging that we're spending time on. That if we had access to the data that was already modeled, it's much faster.
Is that what they call data democratization, Rochelle?
To some extent,
The user can use their data?
It's probably a little different concept. Think about, this is about, we're designing for multiple users and multiple use cases. It's about how we use the data in an analytic way rather than in a transactional way. So it is a different way of thinking about the data and modeling the data so that it meets those needs.
So you don't have to get your data specialist to get your answers. You can do it yourself.
Yes, that's the goal. Steve?
So this may be premature or too ambiguous, but I guess I'm curious, Rochelle. Of course, I'm totally in agreement with everything that we've seen and that we're talking about, but would NWCG be able to provide guidelines for data sets that would better accommodate this kind of mapping, better allow those relationships to be defined in advance, regardless of what the subject area or the business line is? Does that make sense?
I think so. So what I would say, Steve, is that I think, this becomes part of thinking about our data differently than we've done it before. We've thought about our data from an application perspective, right? It's, we know that we have this information in 209 and we just want to add a field, or we want a new report, or IROC build us a new report, or Irwin build some dashboard, right? And this is elevating the way that we think about our data and looking at it from an enterprise perspective. And so one of the things that Cheryl and Nick and Robin and others and I have been talking about is that in looking at fire environment as the focus for these proof of concepts, we really want to look at it as a business subject area. So part of what we want to do is not just look at the fuels moisture database, right? In this effort, we want to inventory all of the data that's used in fire environment. We want to understand all of the applications and data sources that are used in fire environment. And we want to understand the products that are produced for fire environment. And if we can get that total picture of the whole of fire environment, then we can start seeing, oh, hey, you actually are getting, this data from 2 different places. Do we need to have it from 2 different places? Are these the right 2 places to be getting it from? Can we consolidate that? Can we make decisions about one place versus the other? Can we, we've got 3 different applications that are producing the same type of report, right? Let's collapse that and put it at the enterprise level, right? So right now we haven't been able to have those conversations because we've been very application focused. So this part of this learning curve that we're going to be on is how do we start thinking about data from an enterprise perspective, and how do we start making decisions and developing guidance. So the role of NWCG in this, right, is standards and guidance. And so the data management committee and the other business committees have roles in that. The data management office and the data management program as a whole have roles about governance. And then we have the infrastructure and application side of it that are implementing and delivering, right? So all of these things have to kind of start working together in a way that we haven't necessarily done. Some of us have talked about it from time to time, and in some ways we're trying to do it, but this is really going to be a big learning opportunity for us in thinking about who does what in relationship to our data and how do we think about it from a more holistic level. Cheryl?
Yeah, and I can totally see that we're going to have to be really iterative with the application side, because it's like we see it in fire danger mode, but it seems like our culture is to focus on the application and work our way back from there into what we need, as opposed to letting the data and analysis kind of open our box, and then we can find out that, oh my gosh, we could apply this data, this analysis to this, or that, or that, or that. We've never thought about it that way. And so I can see this culture change being rough, though, because we are so application focused.
Yeah, we're not bounded by the walls of the individual databases anymore.
Yeah. Yeah, it is a cultural change, and that's, I think back when we started with Irwin, it was, it was a shift in the way that we thought about stuff. It was a shift in thinking about who owned the data and who should manage the data. But I would say we've done that, and we have that in and of itself puts our community ahead of the curve in lots of ways. And so because we understand how interdependent our business processes are on the same data. And so now we're just taking that concept that we've had and we're just taking it to the next level, right? This is a natural maturation of our thought and our understanding of our data environment. Steve?
Yeah, this is a great conversation. So kind of providing maybe an alternate view to what Cheryl had said is, you guys know I say this all the time, we should start with the business needs first and then work our way backwards. So as a quick example, Megan Kephart this morning began a series of started an email chain that came out of Maryland where they said, hey, we can't get the archive fire danger adjective values, which we put on the fire report, because there's some problems with that data set. And, when I got done taking my whack at that, it's like, well, why are we putting fire danger adjective on the fire report? What was the business need? And, that's notoriously bad data. And so, anybody that actually has a business need to correlate fire occurrence with fire danger would probably soon recognize that that's a bad data set, and they would go get another data set and do those correlations based on something that's more reliable. So in addition to what Cheryl's saying, which is, kind of framing this, shifting our focus away from what can the applications do or what have they done, fixed cost or sunk cost, biases are one of our real nemesis, but, shift away from what the applications have done and look at what the data can tell us, which I think is what Carlos is talking about, but also, just really focus on what the business needs are and work backwards from there. And we'll see with things like the fire report. I don't think you should necessarily put fire danger adjective for that day on the fire report. You can, but when you really start thinking about it, the quality of the data sets and how that data gets used, that's not where you're going to get that information anyhow.
Yeah, I that's one of the things I really like about the approach that Carlos and the team has taken, is that when we talk about an analytic architecture, then if you look at the diagram, we're really starting on the right-hand side. What are the questions that we need to answer? Then we work backwards. What is the data? What do we need to do to the data to be able to answer that question? And where do we need to get that data from? Instead of the other way, right? So it's really driven from the right side of the diagram and the business need back through the data.
Yeah, I think that's an important point. I make it all the time, and that's why Rochelle just stated it too, that the first question you want to ask in this type of architecture is, what do you want to measure? What metrics do you want to see? And the metrics could be about data that live in multiple databases. And you guys just talked about being application centric, but that data could live in outside your organization. And maybe it's not even owned by your organization. It's third-party data. It's data that's available from other agencies. It's publicly available data that all coming together may answer those questions. And that's often what our job is you tell us what you want to measure and we'll figure out how to get the data there and model properly. And as opposed to trying to come up with something you want to measure of data you already have, right? It's that other way of looking at it, open up that world, where, data like this could include HR data, could include salary and payroll data, right? How much is this costing me, right? Or some people want to see that, right? Some people want to see things along those lines. How many hours of human resources are we spending here? Things along those lines. That, again, once you start asking those questions, that data is in a lot of different systems. And but that's the approach that we want you to take, is what do you want to measure?
So I have a question, because it's kind of bugged me. I mean, because on this particular example shows sites sampled, or, that were treated. And then you said that there was a gap, that the last sample date was 3 years ago, but I don't see acres treated. So, for example, like I know some people are on a 5-year or a 7-year rotation, so they may not be treated every year if they're putting fire on the ground. So this doesn't make sense to me just yet.
It's not treatment.
It's fuel sample, how much moisture
Oh,
is in fuel.
Oh, okay, so it's
So
not.
you could do it differently
Yeah.
for what you're saying, yeah.
Yeah, and Travis or Cheryl or others could probably speak to it, but this samples can be taken at different rates, right? Some areas.
Yeah, you nailed it. Sampling is to validate fire danger, as opposed to a project validates the treatment that goes over the acreage. So they're subtly different.
So with some of these been treated, where they had taken the samples?
I don't know if that matters.
No, that doesn't matter. The sampling location should be representative of where the larger fire danger issues are, and where you might have multiple sites out there that might have an expected treatment that's going to occur on them. But the sampling location may or may not be on an individual site. Think of it more like the RAWS station versus a Kestrel on site doing the weather, right? So that's the idea behind sampling, is to dial in what all of the other information that's being calculated is showing. And I would defer to Cheryl and Travis.
Yeah, it's more a focus on like a PCs or like a fuel type. So used with both fire behavior and fire danger. Trying to judge when something might burn, or yeah, the potential of it.
So one of the things that was mentioned was the potential to sample other things from the field, and if you're talking about fuel loading, for instance, that would be something where that would be of interest to people that are looking at fuel treatment effectiveness. So those are the types of things where, from application to application, or even person to person who's looking at it, and what question are they trying to answer, we'll want to see that data work well within those different worlds.
One thing that's worth pointing out is that the architecture diagram is a little complicated, but what it's designed to do is take in any data from anywhere: satellite data, weather data, GPS data, text data, and bring it in to support a specific use case like we built here. But then once you have it in there, you can, because the way it's designed, you can easily blend it together to form completely new visualizations on data sets to answer questions you don't even know to ask right now, but probably would want to know.
Yeah, it was really interesting when we were having the conversations with the USDA, EDAPT, and the Forest Service CTO teams. One of the things they said is, well, they were trying to separate this from transactional data. And they said, well, you've got your systems of record, and this is not a system of record, so we don't, we're talking about uptime and some of that type of stuff. And I said, I think what we're really talking about moves beyond that concept of system of record, where we had this sense that, the system of record is the one place that you go that you get this. And so what they were basically saying is, so if this goes down, it's not a big deal because you've got the systems of record that you can go back to, right? And I said, no, because we are creating new information in this environment. And when I told Travis that, he was like, no, because I'm going to build operational processes off of this new data that gets created in this environment. And if it goes down, it's going to be problematic because going to the source systems to get it is so problematic, right? That you can't actually build those processes today. And so that's part of our conversation with the CTO staff, is that, right, like that idea kind of shifts because we are actually going to be creating new information in this environment that we haven't had elsewhere. Chuck?
Yes, thank you. So you can hear me okay?
Yeah.
Great. Hey, so I just had a question. I put it in the chat. I'm not sure if folks knew that, but I was asking about thinking ahead, maybe decades, to basically multi-dimensional gridded data, such are used by meteorology and other environmental fields. Can this architecture handle such data sets? Or could it be made to?
What was the data set?
Yeah, what is the data set?
Net CDF and GRIB, so basically like 3-dimensional plus time, so multi-dimensional fire environment data sets that are massive and are generated every 3 to 6 hours globally,
Yeah,
or at least across the continent.
Yeah, so, ideally, right, this can handle any type of data. Mostly because there's multiple, I talked a little bit about the multiple zones of data, and just to kind of talk about that a little more. This data is definitely what we would call the analytic zone. It's curated, it's transformed, it's basically based off of business requirements or a need, business need.
The data you're seeing up here.
Yeah, the data you're seeing up here. The data, but the data all comes into what we call a raw zone or a landing zone. And any data, regardless of the data you're seeing here or the data being asked about right now, would land there. So the architecture would be able to store that data and as much of it as anybody can store. There's no limit on, this is all in the cloud. So essentially storage is unlimited and depends how much money you want to spend, right? But it's all essentially completely expandable, infinitely expandable. And so raw data though gets transformed, and very few people really should be using raw data as far as for doing their analysis. Typically we recommend that advanced analysts maybe use the raw data zone for their analysis, but everybody else would want to use the analytics zone. But essentially data like that would have two uses: as raw data in a highly distributed database environment that could be accessed quickly by an advanced analyst, but it would also then be transformed through the pipelines into the refined zones and analytic zones and related to other data that's important to it. And that transformation could be very complicated. I'm not saying it's a simple, again, like Rochelle's saying, we'll end up creating data that doesn't exist otherwise, or measures that don't exist otherwise in the organization because of the nature of the transformations. Different categories of data are created, different ways of group the data together, different ways to report on it. And so that all gets transformed as it goes along. And again, it's intended to be highly, it can grow to a size, an infinite size, right? Highly distributed database, massively parallel processing. If you talk about it in a technical sort of way, this architecture can handle any of that. And that's the idea. Now, in the end, maybe I'm looking at a dashboard like this. It looks like I have 10 charts or 10 lines, but that came from millions and billions and billions of rows of data. We've been working on a project that for one of the state governments for Medicaid and moving it to the cloud. And, they have 1.4 billion rows of Medicaid transactions, right? Or things like that. And, their current on-prem system was dying, but in the cloud, it's nothing really, right? It's meant to work with that, and meant to work with it fast, much faster than it would in their old on-prem systems. So I don't know if that's the question, if it's the massive amounts of data or the type of data, but both, again, can be handled either through an advanced analyst knowing how to use that data, the data being properly transformed so other people can use it, and the size should be handled by the architecture itself.
And I think that's one of the things that I really wanted to make sure we covered with this is that, as we talk about projects like DART and resource tracking, we talk about all of, with Bill, we've got, these partnerships with NASA and NOAA, and we're always talking about satellites and balloons and, all of this stuff. It's like, well, that's a ton of data coming in. It can be coming in very quickly and it can be changing. And if we're running analytics against it, that takes a lot of processing power. And so part of this is about positioning this architecture to handle that as it grows and evolves. And so that was a really important component of it, is that it needed to be designed in such a way that we can handle these multiple types of data and large volumes of data that we haven't actually spent, we haven't been able to capitalize on as much as we would like to in the fire environment.
Do you mind if I ask another question? Because you showed something that some things hadn't been checked on for the last 10 years. Is there any validation on those sites? Have they been nuked out by a large, massive fire, or stand replacement fire, for example? Do you guys have any data on that, or?
Well, we don't, because the data set right now is just limited to the fuel moisture samples. If that data is out there,
if it's a stand replacement fire, you're not going to have any fuel left.
Right.
Well, these sites, though, the fuel sites are actually going out there pulling.
But some of them hadn't been checked for 10 years, and that's what I was asking, if you have any validation on those, if those have been stand replacement fires at some point, so they're not checking them anymore.
Mm-hmm.
That's all I'm asking.
I don't know.
Yeah, I think,
I think it's the local unit's job, right? That are decommissioned, decide if it's no longer usable.
yeah. So I think what I'm going to do, go ahead.
Oh, I was just gonna say, Carlos, remember we talked about orange instead of red. Yes, there are valid reasons why sites may fall off and not get dropped, but I think focus on the capability of you can learn more about this information. So.
Yeah.
Kind of like Wednesday.
And by the way, I noticed I'm wearing a Google Cloud sweater, so I should take it off because this isn't done in the Google Cloud. And you get a lot of free stuff in this business, so you wear it right. But this is actually.
Texas A&M.
What's that?
Just get them a Texas A&M sweater.
Yeah. Did you want to say something? Because I can show this last one.
Yeah, let's
really
do this
quickly.
real quick and let's take a break at 3.
Yeah, so this dashboard is me, right? Nobody gave me this requirement. I just said, what can I find out about the data? I'm gonna do something with it and try to make it look kind of pretty and see if I can understand something about it. So as you see over here, I have a couple of slicers by year and by GAC. I've got 4 GACs chosen, 1 year. So I'm looking at the data for 2021 for those 4 GACs. I can see the average fuel moisture for each month. I can see the average moisture for the most sample fuels and compare them against each other, right? I guess I'm looking at the right side of the chart there. And I can see the minimum moisture that I've gotten for those fuels in 2021 for those 4 GACs. So you see that the 10-hour fuel is 8.7, right, is my least or my driest area, I guess I would say. How we've sampled the states, how many, again, this is not unique samples or unique fuels, this is just how many times we've sampled in the state on the left, bottom left, and then we can see the map. I can hover over the map and again, drill in a little bit on this or zoom in and, let's say I'm interested in this area in Wyoming. I can look at that and see the chart change just to see what we've got there. You see that we've only had 18 samples there, and we had a total of 10,500, I think, to start with. And I can use this in all different ways. I can look at Wyoming this way. So now I just see all the sites in Wyoming that have been sampled. And again, I can see the average fuel moisture by GAC, which is the Rocky Mountain one for Wyoming, and so on. But again, this is just me playing with the data and trying to understand how I could use it. And this is what we want to do for anybody, right? Anybody who understands. Obviously I'm not a fuel moisture expert, but anybody who is may want to do stuff like this or something more interesting, maybe, But it's that easy again with the data model for me to put these together, right? And just come up with things that I think look interesting and what might work for other people. If I want to, focus in on Alaska and not look at anything else, I can do that. And I think our map for Alaska doesn't show because it's
Bigger than Texas.
it doesn't. It actually doesn't zoom out to Alaska, I don't think. But let's get rid of Alaska here. And this one doesn't behave sometimes too when I want to clear it, so sometimes I have to refresh it. But anyways, I was just trying to show capabilities, I guess, there, right? The things you can do, you can build a map, make it a little more friendly to people who like to see things on a map. You can build other different types of charts and graphs, things that compare one thing against the other, minimums and maximums. All those things could be built with this. And generally speaking, right, it's easy enough even for me to do it and not being an expert, in field sampling. So just want to show this. Any questions on this or any comments?
So one comment. So if you're a fuel moisture expert, you could, and you knew Tableau or Power BI, you could go and create a new dashboard with that existing data. Pretty easy.
Right.
Now, if you wanted to bring in like salary data or number of hours worked, that's another data set. If it doesn't exist in the architecture, we have to go bring it in. Once it exists there, then you probably need a guy like Mike to come in and integrate it and create a new model, blend the model, right? Models together, and then the person who only knows the visualization tool can easily create a dashboard off it. So depending on the complexity of what you want to do, it depends on who you need to help create that visualization. So Mike, we didn't show all your pipelines that you create behind the scenes.
I think that's next.
Oh, you will, okay.
Yeah. So let's take a 15-minute break. And then we'll come back and Mike's going to show us the pipeline transformations, which are like the really cool part.